Hi everyone, you are welcome to your favorite learning channel. My name is Oluwatoyin. Today we are going to discuss about the IUPAC nomenclature of alkana and alkanone. The IUPAC nomenclature of alkana and alkanone. What are the alkana and the alkanone? They are the compounds of carbonyl. They are the carbonyl compound. Not only alkana and alkanone are the carbonyl compound. The carbonyl. The carbonyl. Not only alkana and alkanone are the carbonyl compound. The carboxylic acid, which is also known as alkanoic, is also a carbonyl compound. Then the quinone is also a carbonyl compound. Then how will you be able to recognize a compound that belongs to the carbonyl group? The carbonyl group or the carbonyl compound. So there will be presence of double bond, that is, the carbon atom from your functional group we double bonded with an atom of oxygen. When the carbon atom from the functional group is double bonded with an atom of oxygen, we call that kind of compound what? A carbonyl compound. A carbonyl compound. So let's first look at IUPAC nomenclature of alkana. Let's first discuss about IUPAC nomenclature of alkana. Alkana. What is the functional group of alkana? The functional group of alkana is CHO. CHO. While the general formula for alkana is RCHO. RCHO. So RCHO is the general formula for alkana. So which shows that you can derive members of alkana from RCHO. Then another name for alkana is called aldehyde. 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 So you can call it alkana, you can call it what? Aldehyde. Aldehyde. So the general formula for alkana or the aldehyde is what? Is RCHO. So therefore, you derive the molecular formula for members of alkana from this general formula. So don't forget that the non-hydrocarbon starts with the following prefix. The non-hydrocarbon, that is the alkanol, alkanone, alkanoate, alkana, and alkanone, starts with the following prefix: methan, ethan, propan, butan, pentan, hexan, octan, nonan, then decan. So this is their prefix. They start with the following prefix. The first member is what? Methan. We start with methan. So all you need to do to derive their name is to add their name ending. So in case of alkana, the name ending for alkana is al, which is called al. So all you need to do now to derive name for the 10 members of alkana is what? Is to add the name ending. So add al, which is the name ending, to the following. So the first member will give you metana. The second member will be what? Etana, then propana, pentana, butana, pentana, hexana, heptana. 7 is heptana. Heptana, then octana, nonana, and the decana. So this is how to derive what? Name for members of alkana. Then the next thing is to be able to what? To derive their molecular formula. So you get their molecular formula from this general formula. You get their molecular formula from this general formula. Then don't forget that R is representing what? An alkyl group. R is representing an alkyl group. Then the molecular formula for an alkyl group R is what? CN H2N plus 1, then you have your functional group, which is CHO. So from here now, you can derive the molecular formula for members of what? Members of alkanal. You derive molecular formula for members of alkanal. Now, what would be the molecular for the first member? The molecular formula for the first member. So the number of mole from this general formula, that is N, for the first member is 0. N for the second member is 1. For the third member, 2, 3, 4, 5, 6, and so on and so forth. Now, to derive the molecular formula for the first member, you substitute this 0 into this general formula. C times 0 will give me 0. So C gone. 2 times 0, 0 plus 1, 1. So this one will remain 1H. H, then plus your what? Your functional group, CHO. So this is the molecular formula for methanal, which is the first member. So what will be the molecular formula for the second member? My N will be 1. My N will be 1. From this general formula, C times 1 will give me C. 2 times 1, 2 plus 1, that is H3. So CHO. So you add your functional group. So for the third member, my N will be 2. C times 2 will give me C2. 2 times 2, 4 plus 1, 5. H5. Then your functional group, CHO. Then the fourth member, my N will be 3. C times 3 will give me C3. 2 times 3 is 6 plus 1. That is H7. Then plus your functional group, CHO. So, and so on and so forth. So you can derive molecular formula for other members of alkanal like that from this general formula. So you must be able to recognize your functional group, because the functional group will determine the structure to which an organic compound belongs to. Functional group will determine the compound, that is, will determine the compound of an organic compound. So you recognize an organic compound by the what? By its functional group. By its functional group. Now, these are the first 8 members of alkanal. So how can we draw the structural formula for each member? How can we draw the structural formula from each member? So let's first start from our general formula. Let's start from our general formula. So the general formula is R, then followed by your functional group, C, then H, then the oxygen will go with what? With double bond. So we recognize this as a carbonyl compound due to the presence of this what? The carbon atom from your functional group double bonded with what? With an oxygen atom. So when you see any structure in which the carbon atom from the functional group is double bonded with an oxygen atom, so such a compound belongs to what? A carbonyl compound. It belongs to a carbonyl compound. So this is the structural formula for the general formula. Now let's draw the structural formula for the first member, which is methanal. For the first member, methanal. So the molecular formula for the first member is HCHO. That is the molecular formula for the first member. Now, let's look at the structural formula for this molecular formula. First thing, bring out your functional group, which is CHO. Draw the structure of your functional group. Draw the structural formula for your functional group first. So from my functional group, I have one carbon atom. Then don't forget that the carbon atom must be what? Must be bonded with another carbon atom. So this chemical bond, so plus this carbon atom, then the hydrogen will go with what? With a single bond. Then your oxygen will go with what? With double bond. So this is the structural formula for what? for your functional group. Then remaining hydrogen at this side, then attach your hydrogen atom. So this is the structural formula for methanol. Methanol. This is the structural formula for methanol. So let's draw the structural formula for ethanol. Ethanol. Then the molecular formula is CH3, CHO, CH3, CHO. Write the structural formula for your functional group first. So your functional group, carbon atom with oxygen. Oxygen will go with double bond. Then your hydrogen with what? With a single bond. Then at this side now, we have one carbon atom. So attach that carbon atom. Then each carbon atom must be surrounded with 4 chemical bonds. 1, 2, 3, 4. So how many hydrogen atoms? So bring those what? 3 hydrogen atoms. Bring in those 3 hydrogen atoms. So this is the structural formula for ethanol. For ethanol. Then let's take one more. Propanol. Propanol. Before we move to naming. Propanol. Propanol with molecular formula of C2H5CHO. That is propanol. Propanol. So draw the what? The structural formula for your what? For your functional group first. Your functional group, carbon atom, then oxygen will go with double bond, then hydrogen will go with what? With a single bond. Now at this side, how many carbon atoms? 2. So attach those 2 carbon atoms first. Then surround each carbon atom with 4 chemical bonds. 1, 2, 3, 4. Then this one, 1, 2, 3, 4. So how many hydrogen atoms now? 5. So bring in those 5 hydrogen atoms. So this is the structural formula for propanol. Propanol. So let's look at a structure of alkanol. Let's look at a structure of alkanol with substituents. Let's look at a structure that has what? Substituents. Now, under naming of alkanol, the first step to take is to select your longest continuous carbon chain according to the rules that guides us, IUPAC Nomenclature. You select your longest continuous carbon chain. Then after that, you consider your functional group. You consider your functional group. So name from your functional group side. So you number from the carbon atom that is holding the what? Your functional group this time around. So let's look at this structure. Now, this time around, well, this is our what? Our root hydrocarbon. Then we select the longest continuous carbon. So this is the longest continuous carbon chain, the first step. So the longest continuous carbon chain, then you number from your functional group. Number from your functional group. Under alkanol, consider what's your functional group in numbering. So number from your functional group. 1, 2, 3, 4. This is the longest continuous carbon chain. Now CH3 is what? Is a substituent. I've explained all those things in my last video. Then the CH3 is under alkyl, is an alkyl group. So CH3 is called methyl under alkyl. Under alkyl. So alkyl is what? Is always what? They are always substituents. Alkyls are always substituents in organic chemistry. So the first member is called methyl. The second member is called ethyl. The third member is called propyl, butyl, pentyl. Then methyl, the molecular formula for methyl is CH3. Then ethyl is C2H5. Propyl is C3H7. Then butyl is C4H9. So if you want to learn more about alkyl group, check my class on IUPAC nomenclature. Check my class on IUPAC, my video on IUPAC nomenclature. So CH3 is what? Is a substituent. Is always a substituent. Then under naming of organic compound, you name your substituent from the end. You name from the end, which will give you the lowest to your substituent. Name from the end, which will give you the lowest to your substituent. But this time around, under alkanal, we consider our functional group. So you name from the your functional group side. So this time around, you name from this functional group side. So 1, 2, 3. Your substituent, which is methyl is on the what? Is on the third carbon atom. Methyl is on the third carbon atom. So you name your substituent before your root hydrocarbon. In organic chemistry, your substituent must come before the root hydrocarbon. Then your root hydrocarbon is the longest continuous carbon chain. The longest continuous carbon chain is your root hydrocarbon. So CH3 is our what? Is our substituent. So we name our substituent before the longest continuous carbon chain. So what is our substituent? Methyl. Then the methyl is on the third carbon atom, so you call it 3-methyl. 3-methyl. Then your root hydrocarbon 1, 2, 3, 4 will be the fourth member of alkanal. Since we are under alkanal, it will be the first member of alkanal, because the fourth member of an alkanal is the one containing 4 carbon atoms. The fourth member of an alkanal is the one containing what? 4 carbon atoms. So the butanal, from butanal we have 3 carbon plus 1 making 4. So it shows that butanal is the one what? Containing 4 carbon atoms. From the root hydrocarbon now 1, 2, 3, 4. So we have 4 carbon atoms. So the root hydrocarbon is what? Is butanal. So it will be 3-methyl butanal. So the name of this structure is 3-methyl butanal. 3-methyl butanal. So let's take more than one substituent. Let's look at a structure that contains more than one substituent. Now this time around, we are having more than one substituent from our structure. We have more than one substituent. We have more than one substituent in our structure. Now we have CH3 here. We have C2H5 here. Then another CH3 here. Then when we have two different substituents, when there is two different substituents, you name them alphabetically. When you have two different substituents, you name them alphabetically. So we have methyl here. Then C2H5 is called ethyl. We have ethyl. Then CH3 is what? Is methyl. Now, alphabetically, E comes before M. E comes before N. So it shows that we are going to name ethyl before methyl. So let's select our longest continuous carbon chain. Then you number from your functional group. You consider your functional group. So number from your functional group. 1, 2, 3, 4, 5. Now, our ethyl, which will come first, is on the third carbon atom. So we call it 3-ethyl, comma. Then methyl, another substituent, which is methyl, is on the second carbon atom, 2, comma. Then because we have 2 methyl, the second methyl is on the fourth carbon atom, so we have to bring them together. 2, 4. Then how many? 2. 2 means di in chemistry, so dimethyl. Then your root hydrocarbon, 1, 2, 3, 4, 5. Your root hydrocarbon will be the fifth member of an alkanal. It will be the fifth member of an alkanal, or an alkanal with what? With 5 carbon atoms in its molecule. An alkanal with 5 carbon atoms in its molecule. Then if I derive the molecular formula for pentanal, so the number of mole for pentanal is 4. So if I substitute 4 into my formula, CnH2n plus 1 CHO. If my N is 4, 4 times C times 4 will give me C4. 2 times 4 will give me 8 plus 1, that's 9. Then with our functional group. So how many carbon atoms are we having from this molecular formula? 4 carbon atoms here plus 1, making what? 5. So it shows that an alkanal with 5 carbon atoms is what? Is pentanal. So 1, 2, 3, 4, 5. So an alkanal with 5 carbon atoms is called what? Pentanal. So our root hydrocarbon is pentanal. So the name of this structure is 3-ethyl 2,4-dimethyl pentanal. 2-ethyl 2,4-dimethyl pentanal. So let's look at another structure that contains a mixture of organic and inorganic substituents. Let's look at another structure with a mixture of organic and inorganic substituents. Now, we have 2 different substituents from our root hydrocarbon. Let's select our longest continuous carbon chain. 1, 2, 3, 4, 5, 6. There's another chain here. 1, 2, 3, 4. 4. 1, 2, 3 plus 3 here, that is 6. But the best is what is this? This long, the longest continuous straight chain will be the best. Now, 1. Now, we have 2 different substituents now, that is chlorine and C3H7. Then C3H7 is what? Is propyl. This is propyl. Why chlorine will sound chloro in organic chemistry? Chlorine sounds chloro. So we call chlorine chloro. Now we have a mixture of organic. Chlorine is an inorganic atom. Why C3H7 propyl is an organic molecule. Is an organic substituent. So when you have a mixture of organic and inorganic substituents, you name your inorganic before organic. When you have a mixture of organic and inorganic substituents, you name your inorganic before organic substituent. So chlorine is inorganic, so we name chlorine first. Then chlorine is on the second carbon atom, so we call it 2-chloro, comma. Then our second substituent, which is propyl, is on the third carbon atom, so we call it 3-propyl. 3-propyl. Then let's look at an alkanal with 6 carbon atom. With 6 carbon atom, it's in its molecular formula 1, 2, 3, 4, 5, 6. So an alkanal with 6 carbon atom will be the sixth member of what? Of alkanal. 1, 2, 3, 4, 5, 6. So the sixth member of alkanal is called what? Hexanal. Hexanal. So the root hydrocarbon. So after naming the substituent, we have named the two substituents. Then we name our what? Our root hydrocarbon, which is the continuous carbon chain. So which is called hexanal. Hexanal. So the name of this structure is 2-chloro-3-propyl hexanal. 2-chloro-3-propyl hexanal.